Alright, Crewton Ramone Tutoring with another screencast covering tutoring session. Notice how we start off with x squared, 3x, and 2. Actually, we've done more than this, but this is when I started taking pictures. This student basically came for math enrichment. Yay! Not because he was an F student, not because he needed help last minute with a test, but just because his parents want to ensure that he does well in mathematics. He had the multiplication tables pretty well wired. Fractions were giving him a little bit of just small amount of problems, but after that, after like, well, geez, not even an hour, he realized that fractions weren't really that difficult because he could see what he was doing. And we found that his add-ins, he had some problems with add-ins. Actually, he had his multiplication tables down, but like if you asked him what 8 and 5 was, he'd have to count on his fingers. So we got that taken care of. And then we reinforced it with this, which is algebra, of course. X squared, 3x, and 2 gives a chance for him to start fooling around with the small add-ins, right? Just 2 and 1, and then worked our way up. So by the time we got over here, we're factoring 6. We get 3 and 2 is 5, so on. So we can see here that x squared, 5x, and 6, there it is, x squared, 5x, and 6, there are the factors. The little men are standing by to help him make sure he can see, and then you can see that he's doing writing it all down in his book because he is in 6th grade. And there he is, just another angle doing the shot, and he's quite happy and pleased with himself because he knows that algebra, this algebra right here, is quote-unquote high school algebra. This is what the older kids do, so it's making him happy. And then you see over here in his book, he actually had some perspective drawing and then counting how many blocks were in it depending on what angle you looked at it. So of course these blocks are perfect for that. So we drew pictures of this as part of what we did. And then we saw that, hey, we can take 8x and 12, 8x and 15, and 8x and 16 and factor all of those and get the add-ins for 8. And we'll keep going. So anyway, he's having a fun time. We're doing lots of math. We're doing it quickly. Then we did a little bit of fractions. And I showed him that this was the preferred way of doing it, even though some books will tell you to convert them into improper fractions and add them together. I'm like, oh man, who wants to, now I get a common denominator of 56, and I gotta multiply this by 8, and I gotta multiply that by 7, in order to, heck no, let's just add 3 and 2, and then keep the common denominator is gonna have to be no way around it, 56, but now I just have 16 and 35 instead of these huge numbers, and then having to take that, and we'd have to do division to reduce it, and he agreed that yes, this was the much faster way of adding mixed numbers. So that was fun and easy. We did a few of those. And oops, here we are back to some algebra, where we've gotten up to x squared, what is that, 10x and 24. So there are some add-ins for 10 that we're working on subconsciously. We can see, right, 6 and 4 is 10, and of course 6 times 4 is 24, and then we can factor that easily and see how he's starting to, the symbols are starting to come together here with the drawings, so that we move naturally from a drawing of it to just plain symbols. Pretty soon you'll be able to see these things in his head. By the way, this is the second hour. This is 2 hours condensed. This is separated by about a week of time. And there are just the symbols. Quick drawing. Here we can see x squared, 10x, and 25. Oh, look, there's a x plus 5 squared. And later on, I will take him down the road of completing the square and fooling around with square roots and so forth. But right now, what we're doing is multiplication and add-ins. So that when we get 7 plus 8, he doesn't have to be on his fingers. He can just get 7 plus 8, 15, no problem. 27 and 8, 35. You know, it makes math so much easier when you just know it and you don't have to think about it. So here he is. You can see his shirt is blue instead of, or excuse me, red instead of blue. And there he is working on that problem. And then we did some fractions problems. So this is what we're going to do here. Right, some story problems combined time together. And here is the story problem. One person takes 4 hours, the other person takes 2 hours. How long does it take for them to do the job together? So we basically have to do a couple of things here. We find out in the first one how much they get done in 1 hour. So here's the job. If this person takes 4 hours to do it, then in 1 hour he gets a quarter of the job done. Does that make sense? Yes. In this person's part, if he takes 2 hours to do it, then of course he gets half the job done. in 1 hour. Alright, so now we combine, see now, no fun, get back to 1, right? We've got to know what 1 is. So we know what 1 hour of this person's work is, and 1 hour of this person's work together, combined, gives us 3/4. So together, in 1 hour, they get 3/4 of the job done. Now, this symbolizes the whole job, right here, this 4, and this symbolizes the combined work of the two people. So many people want to put a 4 here. So they think it's 1 and 1/4, but it's not. It's 1 and 1/3, and the child can tell me why. It's because this is an hour's worth of work. Then they don't need the whole next hour. They only need one of the hour, one part of that 3-part hour to get together, right? So here's 1 hour, and then 1/3 of an hour. And then later on, when the kids are older, we can take 1/3 and convert that into minutes. And here's another problem. One person takes 5 hours to do the job, another person takes 3 hours to do the job. How long does it take to get the job done? Well, again, we've got to go back, there's the simple methodology. This is how much they get done in 1 hour. This is how much this guy gets done in 1 hour. So now I have 1/5 plus 1/3. And I did this for a class of 5th graders in a school recently, and as fast as I could put those problems on the board is as fast as they could get them after they understood it. The first 3 or 4 slow, and then 4, most of the kids got it, and then 5, 6 problems, and after 7 problems they were making up their own rules on how to do it. And then of course I threw them a couple of curveballs so that they could see what, more reasoning and logic to solving these problems. But anyway, here is, see, because they were able to see a relationship between 8 and 15 and so forth. But then I gave them one where the common denominator was lower. But anyhow, so on this one, 1/5 plus 1/3 gives us a common denominator of 15. Right? We have to make them same before we can add them, and you don't see the work here because he's already done it elsewhere, and we just put the answer there. But now we do see that this is their combined work, 8. Right? In 1 hour they get this much done. The whole job then is 15 parts long. So in 1 hour this is 1 hour, and then the next hour, do they need the whole next hour? No, they only need a part of the next hour. So if one person takes 5 and another person takes 3, then they get the job done in 1 7/8 of an hour. And you can actually see it, right? 7 parts of that 8 is what I need. And I don't need the whole hour, I need 7/8 of it. And it would make no sense at all to use 15 as a denominator. But actually you'll see that on certain standardized tests. Okay, that pretty much covers it. So, Crewton Ramone's House of Math for more.